Hi, this is Bradley Barth with SC Media coming to you from InfoSec World in Orlando, Florida. I am here today with Donnie Wendt. He is Principal Security Researcher at Mastercard. So glad you could join us today, Donnie. Donnie's presentation here at the show was on machine learning and how it can be used both for good and also for malicious adversarial purposes. A very fascinating topic. Let's start a little bit with state of machine learning today. What are some of its most effective applications from a cybersecurity perspective right now? What's working? Where can it still improve and evolve?
Yes, and that's machine learning today provides such profound benefits, but I think even more so the promise that we're seeing in cybersecurity. We really need to embrace a lot of its capabilities to stay at top of cybersecurity. And we're seeing it used a lot in areas across all fields of cybersecurity, starting with things like classifying malware, phishing, all of that, as well as intrusion detection systems, leveraging machine learning and other components of AI. And then we're seeing a lot of growth now is around behavior analytics, trying to determine changes in a system or user's behavior, either over time or comparing them to their peers. And then finally, we're seeing a lot of research now around the area of trying to detect when a vulnerability might be exploited, if and when a new, because only like 3% of the vulnerabilities are ever actually exploited. So this helps us try to prioritize software patching as an industry.
There is a dual nature to machine learning, and that is that it's a technology that's also accessible to malicious actors as well. And so it almost becomes a little bit of a game of one-upsmanship in terms of who's going to have the upper hand in terms of best use of machine learning. So give me the flip side about how malicious actors can potentially either use machine learning or even sabotage the machine learning findings of the good guys.
Right, and that's really the genesis of my presentation. The big part of it was about understanding the vulnerabilities of the machine learning that we're putting into cybersecurity. Because we all know in cybersecurity it's a very adversarial environment. We put a new tool in there, our adversaries are going to try to attack it. So from a machine learning standpoint, a lot of the use cases are around classification. So our adversaries will try to figure out how to circumvent that classification, oftentimes by injecting adversarial samples that will poison the training. And I like to use the analogy of Uncle Ronnie. That was my brother. And when my son was little, before he'd go over to visit my brother, his Uncle Ronnie, I say, please don't learn anything new from him, because I know he's going to teach my son something bad. And then when he come home, I have to make sure, did you learn anything? And if so, unteach him. Well, our adversaries are like Uncle Ronnie in that case. They're trying to teach our own machine learning classifiers to classify their adversarial samples as benign or valid. So when we just take, especially if we're trying to do online learning, where you just put a machine learning tool set in your production network and say, learn from it. The problem is, can you trust that data it's learning from there? Mm-hmm. Can you trust that 100% of the samples going through your current network are valid? Because that's what it's going to learn from. Right. So without that proper data sanitization and making sure you're using valid data to start, you don't know who's training it.
For sure. So what are some of the biggest weakness points for machine learning? Where potentially are some of these malicious actors that are trying to sabotage it or tamper it? How are they getting in the first place? Is it more of, are there flaws still within the technology that need to be shored up? Is it more a problem of the people who are using the technology and making sure that they're using it securely?
And I think it's a lot of process in technology, because the machine learning traditionally doesn't assume an adversarial environment. So yes, if I'm doing my machine learning completely offline, I can secure that environment. I know what it's learning from. When I do that online or in a live environment, now I have less control over what's teaching it. So we have those those poisoning attacks trying to change how it's learned. But then we also have to understand, even if we trained it offline, we have very good training, then we have our production or inference stage attacks. And what that is, a lot of times, is actually adversary using machine learning against our machine learning to try to figure out how ours is classifying something. Once it determines those, really looking for those boundaries between the classes, because that's the weak point. Once I know the boundaries between your classes, then I try to inject something that will be misclassified. Right. So it's really the advent of what we call like adversarial networking, but machine learning versus machine learning is where the future of those adversarial attacks are coming.
And I would have to imagine that the lessons here in terms of what cybersecurity professionals have to watch out for in terms of using machine learning in a secure way and making sure that the data integrity is intact, a lot of those lessons can be applicable to other industries that are also using machine learning. Let's just even say something like healthcare, and you have medical researchers using machine learning to find new discoveries all the time about potential things related to diseases or genetics or anything else. And again, if you have a tampering of data there, the consequences could be dire.
Right. Yes, and it is, a lot of the principles do apply throughout. So first of all, it comes around with that, how do we sanitize that data? How are we sure, are our data scientists doing things like the proper distribution analysis and dealing with cleansing the data it's learning from? And you bring up an interesting one with the medical field, because one of the commonalities there that we've run into from a machine learning standpoint that's real difficult is very unbalanced classes. So a malicious sample is very small percentage of what we're looking for, which is hard for machine learning to deal with. Same thing when we start talking, I assume, with diseases, right? It's a very small percentage. So we have to make sure we have the right data to answer the problem we're talking about. And then also treat that data, that is the ground truth then. That is what we're learning. That's what it's learning from. So make sure you have proper, the version control, access control, all that around your data and your model, so that if there is an attack, or you assume there's an attack, you can go back to prior versions of that data and rerun that model and look for drift and maybe have to investigate further.
So basically, the principle of having some sort of a backup, so that once you detect the point of entry and know that from there the data might have been skewed, you can sort of time capsule it back to when you last knew that the data was correct.
Right. Yeah, basically untrain what Uncle Ronnie just taught it, right? And the other thing is, before we even implement it, we really need to practice. It's what we call adversarial machine learning in our own environments before we implement it. People that come from a traditional software development background like myself understand this. This is something we do. We do it all times, red teaming, penetration testing, whatever you want to call it. We need to do the same thing with our machine learning models. So before we implement them into production, have your security team doing attacks against that machine learning model. So does two things. First of all, you're exploiting it and figuring out the weaknesses, but also it improves your team's chances of detecting an attack, because now they know what to look for.
A lot of potential with the technology, also a lot of peril if not really handled in a responsible manner. So it'll be interesting to see how this cutting edge field plays out over the next few years. Donnie Wendt from Mastercard, thanks so much again for joining us. I'm Bradley Barth with SC Media. Until next time, have a safe day online.